Hello, thank you for joining us for Introduction to Ductless Heat Pumps, Part C, Designing and Sizing Systems. This is the third module out of 4. You do not need to have seen the first 2 modules to be able to get something out of this, but if you're curious and some of these things feel a little new to you as we go through, I may recommend that you go back and check out Part A, Making the Business Case, and Part B, Focusing on Sales. So with that, we're going to jump in and we're going to talk a little bit today about considerations you need to think about with designing and sizing systems. I'm going to say this probably at least 3 or 4 times over the course of this module. This training is not designed to replace actual hands-on training, manufacturer training, or training that you may get through your distributor. All of that training will be critical and monumental to you and your staff actually being able to accurately design and size heating systems. What today we'll cover is an overview of the considerations involved so that those of you that are either new to ductless heat pumps or are considering adding ductless heat pumps as an arm of your business have a better idea of what it is that you're getting yourself into. So what will we get specifically from this module? Well, we're going to cover a lot. But we really want to make sure that you understand the design and sizing concepts involved with ductless heat pumps. Again, this is not going to replace a full training, but we'll wet your whistle to get you started. We do really want you to also understand that taking this module today, we're really going to focus on the basics of a single head ductless heat pump design. So in this case, we mean installing a ductless heat pump head with a single compressor in the main body of the home. We'll talk a little bit more later on this concept called displacement, but this really is what we call a one-to-one system, and that is going to be our focus for electrically heated homes for today. There's a lot you can continue to learn about full system replacement, about adding this to additions and remodels, or even to new construction, but those are all a bit beyond today's scope. Before we jump too much further, particularly for those of you that have not sat through the first couple modules, you may wonder, okay, I hear these names and I'm kind of confused because I see this thing in the lower right-hand corner called NIA. In the lower left-hand corner, I see the Northwest Ductless Heat Pump Project, but yet I work and live in Spokane and we use Inland Power or Avista, or maybe you're in Idaho Power Territory, or maybe you're even in Oregon and you deal with someone called the Energy Trust of Oregon. It can really sound confusing. And I'm going to go into a little bit more detail about who NIA is and who all these different players are. But I want to start by saying the Northwest Ductless Heat Pump Project is one of the programs that NIA runs on behalf and in coordination with all of these other organizations. Really in an effort to maximize and leverage buying power and influence from across the Northwest. So let's go a little bit more in detail on who NIA is. So NIA is a nonprofit organization whose members are many, if not most, of the utilities in the Pacific Northwest. NIA operates the Northwest Ductless Heat Pump Project on behalf of all these utility members. And the goal here is the project offers member utilities research, technical support, promotions, evaluation results, marketing support. Really, again, by leveraging 140 or so different member utilities, NIA can really maximize the benefit that each individual utility, and therefore a large portion of the ratepayers in the Pacific Northwest, that leverage really helps maximize who gets some benefit out of this. And as I mentioned, NIA does run the Northwest Ductless Heat Pump Project, one of many different initiatives that NIA runs around the region that they do so in an effort to benefit maximum number of utilities and therefore maximum number of ratepayers. As we go through today's presentation, we're just required to mention that the images that we see here will either be specifically called out where we got them from. If not, this means they were used from a public sourced image library such as Bing Images, Creative Commons, Wikimedia Commons, or things that have been licensed for reuse and modification, or in some cases, our own image library. The Northwest Ductless Heat Pump Project does have its own image library as well. So just wanted to get that out of the way. As you'll see a lot of these images, they've all been appropriately and properly sourced. So the outline for today, we're going to do a little bit of review, particularly for those of you that are jumping straight into Part C. Then we're going to jump and talk about the sizing needs and concepts. So why is it important that we actually size a heating system? We'll talk about that. We'll talk about what we call this displacement concept. I mentioned this a few slides ago. This is really the idea of instead of replacing an entire heating system, what if we just really looked at the part of the house where people spend the majority of their time, the living room, family room, dining room, and kitchen area. And what if in that area we could install something that really providing heating and cooling at a very high efficient rate? What overall impact would that have to the house? Just leaving the existing system running in the background. So that's what's called the displacement concept, and we'll talk a fair amount about that today. And then we will make sure we touch on what we should do with existing systems. If we're displacing a heat or cooling system, and obviously we're letting that backup system go, well, what should we do with what's left? So we'll talk about all that, and then we'll wind up in this module by giving you some more resources that you can continue to follow up on your education. Again, I've mentioned it before, I'll mention it several more times. This does not replace the need for manufacturer training, and it does not cover really complex system design today. We're really trying to just, again, get you started down this path. So we're going to start with review. You may have seen this before or remember seeing this before if you sat through one of the other modules. If not, we want to talk about this concept that in order to be successful with being a ductless heat pump installer, you really do need to think about 3 or 4 different steps along the way that are going to help you grow your acumen and your business skills so that the product that you're delivering not only delivers for your current homeowners, but it actually encourages them to talk to their neighbors and their friends. So this idea of word of mouth and referrals works in your favor. And this is what we call the path to ductless contracting success. So it starts with gaining awareness. You know, we covered a lot of that in the business case. So what is the opportunity for you in the market, and what are the risks that come with that? What kind of standards of quality do we need to adopt in order to make sure that we're balancing those risks correctly? Then we want to talk about firsthand experience. And what you're doing today is one way to get some experience by sitting through a training. But we also mean actually getting firsthand experience in the field. This means experiencing ductless heating and cooling systems and installing ductless and heating cooling systems. There's only so much you can do without actually beginning the installs, but going through trainings and just gaining great awareness and seeing them operating in other people's homes and businesses is a great way to start getting firsthand experience. Then we want to really focus on sales and marketing. We covered a lot of that in the second or module B of this, and this really does, again, start to think about, all right, how do we take all of this and build a value proposition? What is that we have to offer that should make a homeowner excited, that should get them fired up to want to have a ductless heat pump installed by our company? That is what we mean by building a value proposition. And then at the end of all of this, there's this concept of, after you've done the install, how do you support the homeowners? We're not going to cover that in great detail in this series, but that is part of what we really believe is going to lead you to success in this. And there are a lot of resources on goingductless.com that can really help you at each of these stages. So don't worry if I said that a little fast and you're scribbling it down. We will show you that at the end of today's module. And remember, since you're viewing this either on YouTube or through another video player, you can pause and screen grab any of these slides if there's something in here that you really feel is important. So just remember that as we go through. There's a lot to cover. Don't feel bad if you have to pause and rewind, or if you want to pause and do a screen grab to remember a critical piece of information or to capture a website address. Okay, so what is a ductless heat pump? We talked about this a little bit in one of the previous modules. Most people respond pretty well to taking some relatively complex concepts and putting them in a way that they can relate to. So one of the things you can do is frame this in the context of things they're already familiar with in their homes. So for a ductless heat pump, we can compare that to electric resistance heat. That's the kind of the base comparison, and that is the type of system that we often want to talk about this displacement of. So an electric resistance system is a lot like a toaster, right? It actually operates on the exact same principle. It's just doing a different job. An incandescent light bulb, by the way, also works this way. An electric wire builds up resistance to the electrons traveling through it, and as a part of that, it gives off heat and it gives off light. Depending on the thickness and the amount of electricity that goes through it, you might get a low red glow and get mostly heat, or you might get a bright white glow and a little bit of heat. All of that is from the resistance heating system. So when we talk about your existing baseboard on the wall or cadet wall heater or electric furnace, they all work on the same concept. They're basically glorified toasters. Ductless heat pumps are actually more like your refrigerator. Nothing to really be scared of. It's not exactly new technology. We've had refrigeration in homes and in cars through air conditioning, for tens of years, if not a half a century, of really things that have worked quite well, that we have a lot of experience with and are in almost every home. So we're not talking about putting a ductless heat pump as some groundbreaking technology that no one's ever heard of. We're effectively talking about the same concepts that exist with basic air conditioning and refrigeration, but we're talking about them in a very efficient form with some modernization of some of the parts that allow it to be really, really efficient, really quiet, and pretty fast and easy to install. So ductless heat pump is more like your refrigerator. Your electric resistance heat is really just a glorified toaster. Being able to understand that and communicate that is going to be a great help to you in helping to bring this down to the most basic level of communication that most homeowners can appreciate. A ductless heat pump system has 4 distinct parts, and each one of them, it's important to be able to talk a little bit about it in order to really help convey. I'm not going to spend a lot of time on this. We did go fairly in depth in this in the previous modules, but it's worth repeating. The 4 parts are going to be the indoor head. At the picture you're looking at, that's at the very top, and that is the part where we actually move air over a coil, and that coil is either releasing heat or releasing cool into the main body of the house, depending on which direction the refrigeration is moving through the system. When you move air over that coil, it picks up that heat and pushes it into the room, or it picks up that cool and pushes that into the room, and thus you have either air conditioning or heating. So the indoor head is that part where we transition the heat from outside to inside or move the heat from inside to outside and produce cooling. That is the magic part that actually produces the comfort for the homeowner. Outdoor, we have this thing called the outdoor unit. It's also referred to as the compressor. Now with old heat pumps, this was a very large box that was very loud outside of your home. The modern outdoor units or compressors for ductless heat pumps are small. They're about the size of a suitcase, and they're much quieter. This is, again, both due to their size and due to that improved technology that I mentioned. They use what's called an inverter compressor, which really allows to be ramped up and ramped down quite smoothly as opposed to just on or off at a couple of stages. And because most homes, once they're heated or cooled initially, don't require the system to run at full steam all of the time, that's another level of why we can get these things to be more quiet and unassuming. It doesn't have to run at full speed most of the time. It's a smaller unit with more advanced technologies. So that compressor actually does the job of compressing the refrigerant and allowing it to absorb heat. Again, these systems are two-way systems. They can provide heating or cooling, so it can also send it the reverse and allow the expansion and release of heat outdoors, meaning we've really cooled the refrigerant lines. And in that scenario, we're able to provide cooling to the house. The refrigerant lines, or you'll hear sometimes in the industry referred to as the line set, is the refrigeration plumbing that connects that indoor head to that outdoor compressor unit. This is where that refrigerant travels back and forth between outside and inside. It can either be heated refrigerant because it was compressed outside and absorbed heat, or it could be cooled refrigerant because it expanded outside and allowed evaporative process to happen, which rapidly cools the refrigerant. Either way, these systems are designed to be two-way. Those refrigerant lines need to be well insulated and covered and protected from rodents and neighborhood cats and UV rays. So a total line set that you see on a home may actually be kind of hidden behind something that is plastic or metal that kind of looks like a fancy gutter system or downspout system. That is the line hide that goes over the refrigerant lines. So that's a critical part of the system. Finally, we have the control. Now, the image that you see in the lower right-hand corner is one typically referred to as a wand. These are commonly either mounted in a bracket on the side of the ductless heat pump or are given to the homeowner to be kept somewhere in the middle of the room, kind of like an extra remote control. It's just a remote control for your ductless heat pump system. If this is a bit new and you think that it's going to be challenging for you to really kind of work with homeowners on this concept, most of the manufacturers also do sell wall-mounted controls that look and act a lot more like a traditional thermostat. And if that's something that's helpful for you and how you sell and install these systems, those are quite available and fairly easy to use. So ductless heat pumps, or all heat pumps in general, actually do not magically create heat. They actually just move heat from one location to another. And it's through this compression and expansion cycle I kind of talked about on the previous slide. This is, again, not really that new. We've had refrigerators, we've had air conditioners for quite some time in our homes and in our cars, in our businesses. This is just being done in a smaller package. But what's interesting is when we think about heat pumps, again, they have these outrageous claims of efficiency that's 280% efficient or 375% efficient, and that just sounds strange. It sounds like, how can you produce more heat than you take in from electricity? And again, the answer is we're not actually producing more heat. We're just moving it from outside to inside or vice versa. And even when it's cold outside, ductless heat pumps can still efficiently move that heat indoors. Even your basic ductless heat pump can do this quite well, and we'll talk a little bit later today about cold climate ductless heat pumps, which do it even better. Since the source of the air temperature outside, even when it's cold outside, truly comes from the sun, we can actually say that the sun is heating the earth, which heats the air around it, and it's trapped in our atmosphere. We're actually using solar power to heat that air. So in a way, ductless heat pumps are harvesting solar energy. They're not solar powered. I don't want to make a false claim, and they don't fall into the category of renewable energy, but they are harvesting solar power. So really, this is a pretty interesting way to think about it. Compare this to something that uses fossil fuels. That is also, in a way, solar powered, but it takes a lot longer to create oil or to create natural gas than it does to warm the air. So when we think about efficient use in harvesting solar energy, fossil fuels are on one end of the spectrum, and something like heat pumps are on the other end. And because these things are about 300% efficient, for every unit of energy you expend in terms of electricity to run this thing, you get approximately 3 units in heat, because again, it's about 300% efficient. So you kind of buy one and you get 2 free. It sounds like magic. Again, it's not. This is just a simple act of mechanics and physics. We compress refrigerant, and that allows it to absorb and expand it, allows it to release heat. But it just does it very efficiently. We talked a fair amount in the second, or module B, about creating value propositions. Again, what is it that really resonates with consumers? And we believe that there are 3 really key value propositions with ductless heat pumps. The first is they're really going to save money through efficiency. This means lower heating bills, means less waste, to the point where you can even see a reduction in your overall electric bill, even though you've added cooling to this heating. And that's pretty terrific. And speaking of adding cooling, that's another great value proposition. For a lot of people, when you compare that to installing that window shaker air conditioner or a portable air conditioner that you got to wheel in and out of the room and find a place to store it in the summer, ductless heat pumps, same unit on the wall, can produce that cooling during the summer that for someone who was starting off with electric resistance heat, they didn't have this before. So it's a great value proposition. They're getting cooling out of it. And then finally, both the products and the installation process are fairly reliable and consistent and relatively simple in comparison to very complex central heating and cooling systems. So the resident value propositions: save money, get cooling, do it reliably. That said, we do say these things are simple, and it's more easy to say simple is not always the same as easy. And that's what we really want to dive into today. Is there are some considerations that need to go into this. We don't want to oversell this as that, you just slap this thing together and magically it does all the work for you. You do need to do some thinking about how you want to size and design these systems. And then there is the installation, which we'll cover in Module D. So while it is a relatively simple concept, it's only easy for those that really have mastered these parts of it. So just keep that in mind as we go through. So now let's talk a little bit about displacement concept. There are three important overall things that you need to really understand if you want to think about how heat pumps perform and how heat pumps work. We're going to talk about each of these, and I'm going to warn you, some of this gets a little technical and nerdy, but I'm going to try and keep it on a level that most of us can appreciate and understand. And again, this is a great sign if this is the kind of thing that you say, I'm interested, but I'm not grasping all of it. This is where further education will really benefit you. But if we can at least get you started today, understanding some of the basic terminology and getting why this is important, then you've got the tools you need to follow up. So let's start by talking about how does an ideal heating system work? That's a great place to think about it. First of all, homes lose heat during the winter, right? It's cold outside. Heat tends to go from warm to cold. And even a house with insulation and good windows and decent air sealing still loses heat to outside. In order to maintain a comfortable temperature, we need to produce this and put in the same amount of heat that we're losing. So heat in has to equal heat out, or else the temperature will drop in a home. So if we really want a comfortable, stable temperature, we're really talking about the heat loss of the building and the heat gain. Now, heat gain in a building can come partially from the sun. So solar gains, that's sunlight coming through the window, sun beating down on the roof and heating the whole structure. It can also come from internal gains. All the different equipment we have, turning on and off lights, having people in the home, having 4 plasma televisions, whatever that case may be, each of those are what we call an internal gain, and those contribute as well. But even with those internal gains and those solar gains, most homes still need to have some additional heat added to it in order to get a stable temperature. Wouldn't it be great if we could do this with the most efficient product on the marketplace? That's the goal with putting in a ductless heat pump system, is to produce human comfort at a relatively low cost in a manner that is reliable and consistent, and it's pretty easy to use. So if we're going to do this, we want to really think about, let's identify our customers' needs as well as the home's needs. So the first thing we thought about was how the home may need some additional heat. Now let's talk a little bit about the customers as well. If the home currently has zonal heating, what do I mean by zonal heating? I mean primarily the scenario where you can heat each bedroom independently or individually, or you can control parts of the house one at a time. That is what we call zoned heating. So what's a good example? Baseboard heaters, right? Either at the baseboard itself or on the wall in the room, you have a thermostat in each room. That is zoned heating. You may have a house where you can heat and cool upstairs differently than downstairs. That is zoned heating. So a house that has zoned heating, zonal heating is a great place to start. If the customer has a high need to reduce their bills, if that is one of their driving impetuses, and the consumer would also like cooling, at least in the main living area, and that's a high enough priority, but maybe they don't need it in every room of the house. If they can trigger those three, then displacement heating and cooling is going to be an ideal solution for those homeowners. If, however, the home only has central heating and the customer wants cooling everywhere, and the customer is not quite as concerned or driven by either first cost or their utility bills, then you can start thinking about a total heating solution or a total system replacement and upgrade. We're not here to place judgment that one is better than the other. Our belief, however, is that the top half, the displacement heating solution, is an excellent foray into heating and cooling system replacements in the lowest first cost mechanism for the homeowner. So this is a great way to help a lot of people that don't need all the bells and whistles. They simply want to reduce their bills. They would love to get some additional cooling in the house, and their house has zonal heating. In that scenario, it's a really great place to start with for your business, and it's a really great place for us to start from a technology perspective of getting ductless heat pumps into homes, is going for that first group first. That's where we'll see a lot of success, and that is displacement heating. Another way to think about this is we can look at some visuals, right? So in this visual, we've got an existing system where we've got these little baseboards. So if you look here, you see these red areas and those little gray bars. Each gray bar is a baseboard heating system, and as they come on, they are going to produce heat that will radiate out kind of in line of sight from each of these, and each one can heat the individual room that it's in. And depending on how they're oriented and where your couch is compared to them, they may or may not heat the whole room evenly. I can tell you from experience in one of my previous apartments, we had the couch right up against the window, and right underneath the window was the baseboard heater. It never really felt like the room was heating up quite the same way as the bedroom did, where the baseboard heater was well exposed. So that's a pretty common thing. And this is one of the places where, instead of telling people to move all their furniture, where we can say a displacement solution could jump up the efficiency, also provide cooling, and give them the option to have the heating in a place where it's going to be harder to be disrupted. So displacing this type of system means that we put a ductless heat pump in the main body of the house, and we allow it to do the heating and cooling in that main area. Again, typically the living room, dining room, family room, kitchen, and major part of the hallway. That's a displacement system. We've displaced at least that large baseboard or a couple of large baseboards in the main body, and maybe even that closest bedroom, particularly if homeowners keep the bedroom doors open. When we think about this, we usually think about displacing anywhere from 30 to 70% of the need to heat in the home. It also provides summer air conditioning in that area. It cuts the heating costs in half for the building, but you can still keep those baseboards. In the main body, they can be used for the really, really coldest day of the year where you just need that little extra oomph, and it allows you to still keep heat going in the bedrooms, but maybe you set the bedrooms down a degree or two. So maybe if you have the main body heated to 69 or 70, maybe you keep the bedrooms at 67 or 68. And these two systems are not competing with each other very often. It only really will kick on that baseboard heat when the overall building drops down cool enough. And most homeowners find this to be a very acceptable way to heat and cool their home. If you're looking at total heating, there are several options. There's using multiple heads on ductless heat pumps, one in the main body and others in bedrooms, or ducted mini splits. Or you could do a centrally ducted heating system. We're not going to really talk about those today for two reasons. First being that these systems can be quite complex and hard to cover in an online format. And second, they're really beyond the scope of what we're trying to talk about. We're really looking at getting that initial intervention into a lot of electrically heated homes by at least getting one ductless heat pump in them. That's a very different proposition than saying we want to revolutionize and change everyone's full heating system. We're realistic. We want to get out to the most amount of homes and get the most number of consumers comfortable and happy with this technology in their home. That's going to happen through displacement. So there is a lot of terminology in the HVAC industry. And for those of you that are coming into this perhaps as contractors but not from the HVAC side, a lot of this terminology is going to seem confusing and challenging. Instead of spending a lot of time, we could probably spend 15 minutes going over just this slide. I just want to point out a few things. First, this is a great place to pause this video and do a screen grab of this slide. This will allow you to print it out and have a nice handy frame of reference, but you can also look all these things up on the internet on your own. It's a great place to kind of take that breather and say, there's a lot to digest here. I do want to point out the terms HSPF and SEER, those are the most common heating and cooling efficiency ratings that you're going to see out there. And in both cases, higher is better. So the higher the HSPF, the more efficient the system may be at heating. The higher the SEER, the more efficient it may be at cooling. I said the word may because these rating systems don't necessarily align with how these systems perform in the real world, but it's a decent proxy. A high HSPF and a high SEER likely to be a highly efficient system at both heating and cooling. The other couple things, I'm going to talk a lot about turn down ratio in a little bit, so let's skip over that and talk about design capacity and design load. Design capacity has to do with what is the ability or the oomph, if you will, of the heat pump to produce heat at the winter design temperature for your home. The design load, on the other hand, is how much heat does your house need at the winter design temperature. If you do not produce as much as you need, you can imagine the house may not be very warm. So that's a critical element when we talk about sizing and design, is getting the design capacity and the design load to match, or to make sure that the entire system of the home, if it's a displacement system, so the combination of the ductless heat pump and the electric resistance heat, are capable of meeting the design load. So with that, we're going to go on, but know that there are a lot of jargon and a lot of lingo and a lot of acronyms out there in this industry. It is worth beginning to learn them. I don't encourage you to speak this language very often with the consumer. You're going to want to boil it down a little bit, but the better you can understand it, the better you'll be able to understand and have the right types of conversations with other contractors, distributors, manufacturers, and HVAC trainers out in the marketplace. So why is sizing and design really that important? I did mention just a minute ago about design capacity versus design load. But let's make it really simple. Again, if you want to talk to a consumer about this, if you make the heat pump too small, you're going to miss out on some of the savings because you're going to be relying more on that electric resistance backup heat to do more of the work. That's right there. You're missing one of the main reasons why you would have gotten a ductless heat pump, was to maximize those savings. You also could reduce the comfort with this too small because you just don't have the heating and cooling capacity that you really need for the house. So even though you've got something in the middle of the summer producing some air conditioning, if it's not really enough to do the job, it feels like you're wasting energy because you know cool air is coming off, but it's really not doing enough to make the home comfortable. That's just not a good place to be. On the other hand, if you make them too large, you are increasing the first cost because up front they will charge a little bit more, the manufacturers and distributors, for buying a larger system. So if you radically oversize in your design, you're actually increasing that first cost and maybe even losing out on some sales. You also may not get the savings you think you're going to get. Or the homeowner, in this case, wouldn't really get the savings they think they're going to get. Because an oversized system tends to shut on and off because it has a hard time kind of being in a cruise control mode for a large portion of the year where you only need a little bit of heat. So that constant on and off means the systems don't always run at their most efficient speeds, and that could reduce the savings. And on top of that, it may also shorten the lifespan. If you think about on and off and on and off and on and off versus running smoothly and continuously, that on and off really can shorten the life of everything from a simple switch or a control to the entire system. So it's worth considering. It may not be the biggest consideration, the shortened lifespan, because they do make these systems pretty tough. But oversizing or making these things too big can be potentially problematic in that area. So now let's talk a little bit, really going to nerd out here, but I'm going to try and keep it pretty high level. I talked earlier about heat pump capacity versus design load. So the load is how much heat the house needs to stay warm. You can see this blue line that starts at the upper left and goes to the lower right. That is the heat that's needed at different outdoor temperatures to keep the house at a constant temperature. And if you look at this, it slopes down, right? And that's because when it's really cold outside, you need a lot of heat. And when it gets to, say, 45 degrees outside, you just need a little bit of heat. And in fact, at negative 20 degrees, let's say this is for Boise, Idaho, where they have a 10-degree winter design load. At negative 20 degrees, you would need to produce about 150% of your design capacity in order to keep that house warm. That's putting a lot of stress on a heating system to do that by itself. Whereas if you go to the other end of the spectrum, if you go to 45 degrees, you only need about 40% of the design capacity. So we're really talking about heating systems that need to be very flexible to be able to, a lot of the time, only produce a little bit of heat, and maybe once in a blue moon, produce a lot of heat. And this is the nature of why heat pumps, the modern heat pumps, these variable capacity systems are so great, is they can actually do a lot of this work. You'll notice that from the temperatures of about 35, 40, and 45, that represents something on the order of 65% of the hours in the year are in those temperatures. And that's in the place where you only need 60% or less of your full capacity. So that really is speaking towards this idea of how good is your system at running at low heat and low speed. The better it is at running at low heat and low speed, the better the system will be at not having to turn on and off and creating comfort issues and potential issues with longevity of the equipment. So that's something we're really going to focus on moving forward. There's other ways to look at this. These are heat pump capacity versus the house heating need in a different way to look at it. We're going to look at a standard air source heat pump. If you're not colorblind, it's the gray line. If you are, it's the line the most to the right. And we're going to compare that to an enhanced capacity or a cold climate heat pump, which is the dark red line, or if you're colorblind, the most left line. And here we're going to look at, again, the bottom is outdoor temperature. The side on the left is the percent of the design load that you need to meet. So let's take a look at what can be achieved by the heat pump and what would have to be made up by the other heat in the home. So if you have a standard air source heat pump, right, and this is how much heat the house needs to stay warm, the conventional heat pump, it's going to match around 30 degrees, maybe a little bit below that. It's able to produce exactly as much heat as is needed to keep the house warm. So what happens below 30 degrees? How do you keep the house warm with the standard air source heat pump? Well, this is where you have backup heat. And most homes, that is electric resistance. That could be, in a central heat pump with an electric resistance strip heat. We do see some parts of the Northwest where there's a gas furnace working as backup. But look at how much of that area needs to be really met with backup heat in order to keep that house comfortable. And again, that's because conventional heat pumps really are only able to meet a lot of the design load with capacity at around 30 degrees. But variable capacity, cold, on the other hand, they're able to operate all the way down at, say, 10 degrees. And in this scenario, you only need a small percentage of the time to be treated with backup heat. So you tell me which you'd rather have. A heat pump that can do heating and cooling for the lion's share of the year and only needs backup heat for a very small amount of time, or the previous that we saw where a lot of the time you still had to have backup heat provided even though you had a heat pump. this is not to knock standard air source heat pumps. They are a large leap forward compared to electric resistance heat. But if you really want to maximize that adoption of heat pump technology, looking at these cold climate ductless heat pumps is an excellent place to wind up to really get that maximum benefit. This is just showing that comparison still between that cold climate and the air source heat pump. And while, yes, it is true that the majority of the time is spent where an air source heat pump would do the job, there's still a fair amount at the 15 degree, 20 degree, and 25 degree temperature that would need to be addressed by backup heat if you have a standard air source heat pump. Whereas with the cold climate ductless heat pump, you're only really ever going to need that backup heat for a very, very small percentage of the time. Other ways to look at this, ductless heat pumps are what we call variable capacity. So that means they can slow down both their ability on the compressor side to produce heat as well as the indoor fan to move air. They can slow down and operate at something like 25 or 30 or 40% of its total design capacity for long periods of time and still produce work. Your old school big compressor air source heat pump, the one that you may be familiar with in terminology, typically is not variable capacity, means it runs at 1, maybe 2 speeds. With that, it means they're louder. They do not have as high of a COP, or coefficient of performance. And that constant speed heat pump really is not able to produce a lot of capacity at 5 degrees. Now look to the right-hand column at cold climate ductless heat pumps. They're 160% of the COP of a constant speed heat pump. They're quieter, and they're capable of producing 90% of their capacity at 5 degrees. The standard heat pump is right down the middle between these two. We'll talk a little bit more about this, but effectively, one way to say it is if you live west of the mountains in the Pacific Northwest and you're not at a high elevation, a standard ductless heat pump is probably going to satisfy most of your needs. If, however, you are in an inversion zone, you're higher elevation, or you're east of the Cascades, cold climate ductless heat pumps are really going to be the thing that's going to get the job done for you. Now to this idea of this turn down ratio. I mentioned this, that ability to operate at what we call partial load, or to produce a little bit of heat when you only need a little bit of heat. One way that we can rank this is by looking at something called the turn down ratio. And the higher this ratio, the better. We really like systems that are 3 or 4 in their ratio. And what we're looking at here is rated capacity, and that's measured at 47 degrees, compared to minimum capacity at that same rated number. So here we've got a system, its standard rated capacity is 21,000 BTU, almost 22, and its minimum capacity is 5,400. So this has a turn down ratio of 4. So that's not bad. If it was 6, that would be tremendous, but anything 3 or above is going to be pretty decent. The really good systems have turn down ratios greater than 5. Decent systems have turn down ratios greater than 3. Most cold climate ductless heat pumps have a turn down ratio between 3 and 5, but where they really excel is being able to deliver that 85% of the capacity at really low temperatures. So their best job is at really satisfying you when you're really cold. Whereas your standard ductless heat pump with the higher turn down ratio, its best job is being able to satisfy the building when it just needs a little bit of heat. So just two different ways to think about what's really important and really imagining how this addresses the needs of your consumers. So you really do want to think about selecting equipment that's appropriate for your climate. This good low output during mild conditions, or this high turn down ratio, is really going to be terrific for everything west of the Cascades and things east of the Cascades where you have a very efficient home. In those scenarios, you're going to get increased savings, increased comfort, and a longer system life. So it's an all-around series of wins. If you have a fairly well weatherized home east of the Cascades, or a newer home, or just about any home west of the Cascades, providing it's not at an extremely high elevation, you should be able to get by with a higher turn down ratio standard ductless heat pump. Why? Let's look at it here. The coldest conditions, even in Boise, are 566 hours out of the year. The mild conditions in comparison are 3,000 hours a year. Think about which of these is a much bigger thing to overcome. You really want to make sure you're working well for 3,000 hours out of the year. It's the middle time between the really cold and the really mild, and that's where the well-weatherized home or the newer home that I mentioned can allow you to get away with a standard heat pump even in Boise. If you either have a unweatherized home or you are in another part of the east of the Cascades, that cold climate ductless heat pump is likely to be your best bet. So how do we take this, what we've learned about displacement and about design capacity and design loads, and how do we translate this into recommendations for design? Well, let's go through a couple of things: sizing calculation, then equipment selection, and then making sure that all of this fits the house at the right size. The first thing we want to think about is sizing these. There's a couple of things. The first is, in more complex homes and homes that may have more than one ductless heat pump head going into them, so even though our displacement looks at one, you may have a homeowner who also wants a head in their bedroom or something like that. As we look at either more complex or we really want to solve more than one room's condition at a time, we really need to do room by room calculations for how much heat is lost over the course of the day. This is really going to allow us to put the right size system and then select the right equipment to meet that goal. And there's several engineering tools available. One is the BetterBuilt Northwest HVAC sizing tool. You see a little screen grab of that in the upper right-hand corner. What's wonderful about this is it's free, and it will give you very similar answers as some of the other softwares, such as RightSoft and Elite, which are terrific pieces of software. They do a lot of really good things there, but they do have some pay associated with them. In order to generate them, you do need to pay per run. So while I think that they're terrific software, I'm a big proponent of making this as easy as possible for you. So considering the BetterBuilt Northwest HVAC sizing tool might be a good place to start. If you're just talking about displacement in the main body only, you can use some of these rule of thumb sizing tables. The one we have here is just kind of indicating, a conventional ductless heat pump, what can it really treat versus a cold climate ductless heat pump. And this is for a standard 1-ton system. The older the home, the less square feet it's really going to treat really well. So if your living room, dining room, family room, main part of the hallway and kitchen is more than 400 square feet, you may want to go with a cold climate ductless heat pump unless you've got a newer or better insulated home. There are several common mistakes as well in terms of how these things are designed and selected. The first is forgetting to check the cooling loads. And this is really important if you've got homes with a lot of large south and west windows. You really do want to make sure you're actually doing the cooling loads as well. And some of that simple rule of thumb sizing doesn't really get you there, but that engineering tools will. So one thing you can do, particularly if you notice a house with a lot of south and west large windows, this is a really good time to upgrade your way of thinking to using an engineering sizing tool to make sure that you're going to size your system to actually meet both the heating and cooling loads of the main body. The second is bad compressor location, right? You want to make sure that it's at least covered. Now, obviously, I'm not talking about putting the compressor in the doghouse, but what we mean by that is making sure that it's going to be protected from the elements. We've actually seen outdoor units buried under snowdrifts. That is not going to work very well. You need to have clear space around it. You need to have it not be in a high wind zone and not in a high snow zone. Also, there are sound, local jurisdictions have some sound requirements. Even though these are much more quiet pieces of equipment, there are still some regulations out there. So also making sure that the location of the outdoor compressor meets with all local codes is also a good idea. And then with the indoor head, making sure that you're going to get good distribution. And this means potentially using the right piece of equipment for the right location. In this scenario, if the only place to put the indoor head in this main body was somewhere low on the wall, then don't put a head that's designed for high on the wall. They actually sell these floor-mounted units that could be installed right down at the bottom. So picking the right piece of equipment is a critical piece to not having one of these common mistakes. I mentioned this earlier, most west of the Cascades, turn down ratio is going to be really important, and looking at the capacity of the equipment at around 17 degrees Fahrenheit is going to be what you really want to look at. Make sure you're going to be able to get a good chunk of your load at 17 degrees. Again, if you've got just an ungodly number of windows, or if you have a very high elevation, meaning over 3,000 feet, maybe start thinking about a cold climate ductless heat pump. Most displacement scenarios here can get away with a 1 to 1.5 ton system, or a 12 to 15,000 BTU per hour rated capacity system. If we're talking east of the Cascades, we almost always just recommend a cold climate ductless heat pump system out here. Capacity at 5 degrees Fahrenheit is important because a lot of these will have winter design conditions in that 0 to 10 degree range. So getting something with a great capacity at 5 degrees is really important. Use pan heaters, and you want to make sure that the pan heater is only going to operate during defrost modes. This kind of allows the system to defrost a little bit faster and better. So it will run for larger portions of the hour in its heating or cooling mode as opposed to having to spend time defrosting. But one of the things about pan heaters is you want to make sure that it's only running during defrost, so it's not wasting some additional energy during non-defrost times. And then again, make sure you have some design installation considerations for snow issues. For some people, that may be mounting the outdoor unit on the wall as opposed to on the ground. It most certainly will mean protecting it from wind, rain, and snow. A lot of the homes out in the eastern part of the Northwest will typically go with a 1.5 to 2 ton rated capacity ductless heat pump when they're looking at a displacement scenario. So to wrap that up, west of the Cascades, a 1 to 1.5 ton system with a good turn down ratio is appropriate for most places unless you're at a high elevation or have a ton of windows. For east of the Cascades, in most scenarios, a cold climate ductless heat pump that is 1.5 to 2 tons will probably suffice for a lot of your scenarios for displacement. So what should we do with existing systems that are left behind? Again, remember, we're not trying to replace manufacturer training here, and we're not going to talk about super complex systems. We're just talking about a displacement one-to-one system and just enough to get you interested. So if your existing system is zonal, right? So this is the picture we looked at here. You want to turn down the thermostat all the way down in the main body. All the way down means, you know, lower than 60 degrees if it has a setting that goes down that far. A lot of them can go down as 55 degrees. If it just says low versus high, then switch it to low. That's going to allow the ductless heat pump head to do the heating in that main body in all instances except for something cataclysmic where the ductless heat pump breaks. And then allowing most of the other bedroom thermostats, set them 2 to 3 degrees cooler than the ductless heat pump. And we do that so that, you know, slight variations in temperature throughout the house don't cause them to come on unnecessarily. So it turns out most homeowners are fine with having their bedroom just a couple degrees cooler than the main body of the house. Again, I'm not talking about 5 degrees colder. I'm talking, you know, 2, 2.5, 3 degrees cooler. So setting those back is going to maximize your efficiency with these. Right? This is really going to allow the ductless system to do the majority of the work. But not all houses are set up this way. We have a fair amount of houses with electric furnaces. And so in this scenario, you can see I've got a furnace kind of center in the house and a thermostat on the wall. I'm not going to sugarcoat it. Trying to do displacement with a forced air furnace takes a little bit more finesse and has at least one additional step to really make this work great. So keep this in mind if you're considering displacement with an electric forced air furnace. if you're going to do this, we highly recommend moving the thermostat down the hallway or into one of the bedrooms. Now, that can be challenging because it's wiring enabled. There are some thermostats out there. The Ecobee is a great example that have remote sensors. For Ecobee, they cutely call it the little bee. And you can choose on that smart thermostat where you want to pick your temperature from. So moving it either down the hallway or into a bedroom will mean that the furnace isn't coming on or not coming on because the main body is being heated or cooled. It means that it comes on when that bedroom or the far part of the hallway calls for it. You can also turn down the registers in the main body of the home a little bit. We don't typically do that for efficiency. We just do that so it's not competing with the heating and cooling that comes from the ductless heat pump. And then really instructing homeowners on how to work their system to maximize their benefit. So a future system may look a little bit like this. We've got the thermostat moved down the hallway. We've got the heating register shut off in the main body. We've got the ductless heat pump set up to do the lion's share of the work in the main part of the house. Again, it's possible. It is a little challenging, a lot more challenging perhaps than a standard zonal system, which is why we say zonal systems are really the first best opportunity for a displacement system. But this can be done, and if you can figure out a really nice solution for this, it really does open up a whole segment of electrically heated homes that your competition may not be addressing. So let's look at some summary slides here, and then I'll give you some resources at the end. In all cases, coming to our website, the goingductless.com website, is always a great place to start. And what's great about this website is there are two different ways to view it. When you first land on it, it will automatically be set up for consumers. So there's a lot of information here that you can point consumers towards that will help you do your sale for you, because it's going to be educating the consumers on what to be looking for, what kind of questions to ask. And it mimics a lot of what we're talking about in this training today, but just in very consumer-oriented language. But you can also click on either the contractor or partner link, and that's going to give a lot of resources for you. Everything from sales resources, access to additional trainings and training centers, and a lot more resources that you can utilize and build into your plethora of what you offer to your consumers. There are other websites that also do some great work. This is from Bonneville Power Administration. Again, this might be a great time to do a screen grab so you can get this link down at the bottom because it's a lot. But this HVAC technology guide does cover quite a bit. I'm going to pause for just a second for you to get a screen grab. And now we'll take a look at some of the things that are inside this technology guide. It does a great job of covering the HVAC basics. This is going to help you with the terminology and a lot of those fundamentals. It's then going to go into the variety of HVAC technologies that are out there, way more than you heard about just with ductless heat pumps, but it'll help you see how ductless heat pumps fit into the bigger picture with other pieces of equipment that are out there. And then it'll also do some what we call cross-cutting of how does this fit in with things like building codes and federal standards. So being able to have that kind of understanding, you're going to find a lot of this in that technology guide. So it is something we recommend. You download a copy of this and make sure that your staff have some basic overview and combine this with the additional training we encourage you to get from your distributor and manufacturers. Speaking of that, we try to post a lot of that training opportunity on our goingductless.com website. We have a training and events page just for contractors, and it will talk about a lot of our distributors, and I'm just got a couple of them labeled here. There's a lot more. Just couldn't fit them all on the screen. Same with manufacturers. By the way, these are all alphabetically oriented. These are not in any way, shape, or form oriented in any sort of preference. So, taking a look at the various manufacturers and distributors, the trainings and events that they host are available on our website, and a great way for you to kind of take some of those next steps in your education. So, we've looked so far, we went through part A, which was the business case, which hopefully you've already sat through. If not, I encourage you to do it. It's a 55-minute course, and we'll get you up to speed on how to make a business case for yourself on, is this something I want to invest in with my company? Or if you already are invested in ductless heat pumps, how do I maximize that and get all of my staff on board? The sales basics is about an hour-long one, and this covers new ways to think about how we approach sales. And it really is all about creating value propositions and switching our mindset away from trying to come in and be an expert telling homeowners how they should respond, to instead listening and becoming a trusted advisor, which opens the door for you to be a solution provider. And really thinking from that perspective will boost your sales. And then in this module, we covered the design basics. We do have another module on installation basics, which we hope you'll join us for. And we also have some additional trainings on, including a program orientation and a master installer training. In order to get access to those, you'll need to join our learning management system online at goingductless.com and register and become a registered trade ally. Once you do that, you can get listed on our goingductless.com website, so consumers can find you, utilities can find you, and that actually will open the door to even more resources for you. So please consider that if that's something you might be interested in. We're always interested in feedback, whether it's on this module or on other training or other resources we provide. Feel free to reach out to us, and we're always looking for a few companies that would like to learn more and are interested in really talking to us and sitting down and figuring out how to improve their business. So if that describes you, connect with us at info@goingductless.com. It goes to our central resource, but it will find me eventually. So if this is something you're interested in, we highly recommend it. And we really do want to thank you. We know spending an hour of your time on this really is asking a lot, but we hope this was rewarding for you. We hope you got a lot out of it, and we hope you'll join us for the next module on installation. Thank you so much and have a wonderful day.